You know that feeling in a video game when you finally unlock God mode?
Oh, yeah.
It's that moment where, the laws of physics just stop applying to you. You can walk through walls, infinite health, summon anything. It's the ultimate power trip.
It is. But usually about 5 minutes after that, you realize you've, accidentally deleted the floor of the level.
And you're just falling into an infinite void.
Exactly. Because you clicked the wrong button.
Exactly. And that is the perfect metaphor for what we're talking about today. We are doing a deep dive into the Class 5 notes from CS123 System Administration.
System Configuration Basics.
And if I had to summarize the theme of these notes, it's basically, with great power comes the ability to completely nuke your server.
That's a very fair summary.
Yeah.
We're moving from being a user, where the system has all these guardrails to protect you, into the administrator mindset. So we're going to look at the God mode of Linux, the super user. We'll break down how the system wakes up, the boot process, and we'll tour the brain of the whole thing, the etc. directory.
Right. And just for context, we're working off the Spring 2026 syllabus and notes. Our mission today is to help you understand all this. Permissions, automation, the boot process, well enough that you can wield this power without destroying your homework.
Or the company database down the line.
Yeah, that too. So let's start at the top. The big boss, root.
The root account. So in the Linux world, root isn't just another user. It is the account that has absolutely all rights.
And when the notes say all rights, they don't just mean it can read all the files, do they?
No, it's way deeper than that. Normal file permissions they don't apply to root. At all. You want to read someone's private encrypted file, root can do it. You want to force delete the operating system while it's running, root will just say, sure, here we go. It's the super user.
Which sounds great for fixing things, but the notes point out a really strict security rule about this account right away. They say you should disable remote login for root.
Correct. And this brings us to the why. It's not just about preventing hackers from brute forcing the root password, though that's a huge part of it. It's actually about a concept called accountability.
Accountability, you mean knowing who to blame?
Exactly that. Imagine you manage a team of 5 admins. If they all just log in as root to do their work, the system logs just show root deleted the database. Root changed the password.
Cool.
If everyone's wearing the root mask, the real user becomes anonymous. You have no idea who broke the server.
So it's like a mystery where everyone wears the same costume. You see the crime happen, but you can't ID the suspect.
Precisely. So best practice is you log in as yourself. The system knows you're there. Then you use specific tools to temporarily elevate your privileges only when you need them. And the classic old school way to do this is the su command.
Su. Switch user.
Right. Su lets a standard user become another user. You just type su by itself, it assumes you want to become root. But here's the catch. You need the target user's password. So to become root, you need to know the shared root password.
Okay, but that sounds risky. If I know the root password and I switch to root, I'm right back in God mode again.
That is the problem.
Yeah.
Su is all or nothing. Once you run it, you are that user until you type exit. You have zero granularity. And the real danger, the thing the notes emphasize, is that it's a permanent switch.
You forget.
You forget. You switch to root to fix one tiny thing, you get distracted, and then you try to delete a temp file, and oops, you just wiped a critical directory.
That's the falling through the floor moment.
It happens more than you'd think. Now, there's a subtle technical point here that the notes mention. The difference between su and su dash.
I always forget the dash. It seems so small. Does it really matter?
It matters a lot. If you just type su, you become root, but you keep your current shell environment, all your path variables, your aliases, your current directory, they all stay the same.
Okay, so I look like root, but I'm metaphorically standing in my own living room.
Perfect analogy. But if you type su, it gives you a login shell. It completely resets the environment to be exactly as if root had logged in fresh. It's a clean slate. For serious admin work, you almost always want that dash.
So su is this big toggle switch, but the industry has moved on, right? The notes spend a lot of time on sudo.
Super user DO, this is the modern standard. Instead of becoming root for a whole session, you just execute one single command as root.
The notes have that classic XKCD comic reference here.
Of course. Make me a sandwich.
No.
Sudo make me a sandwich.
Okay.
It's a classic because it perfectly illustrates the idea. You invoke the power only for the exact moment you need it, and the benefits are huge. First, granularity. I can set it up so that you can only run some commands as root.
So I could let you restart the web server, but not say change password.
Exactly. And second, sudo logs who did what? It says user Jane executed restart server. Accountability problem solved. And crucially, it asks for your password, not the root password.
Oh, that's a huge difference. We don't have to share the keys to the kingdom with everyone.
Right. And it even caches your password for a few minutes.
Sure.
So you type it once, and then for the next 5 or 10 minutes, you can run more sudo commands without retyping it.
Which is nice. Now, managing who can use sudo for what seems important, the notes mention a file, etc.
It's the sudoers file. This is the gatekeeper. And listen to me carefully here. There's one golden rule about this file. You never, ever open it with a normal text editor, like Nano or Vi.
Never. Why not?
You must use a specialized tool called the sudo, the file. It might as well be cursed. The syntax is very specific, and the file permissions are incredibly fussy. They have to be exactly 440. If you get the syntax wrong or the permissions wrong, sudo just stops working.
And if sudo stops working, you can't use sudo to fix sudo.
Exactly. You lock yourself out. It's a catch-22. If the sudo is smart, it checks your edits for syntax errors before it saves the file. If you made a mistake, it yells at you and won't let you save it. It saves you from yourself.
That's a good feature. It's like a spell checker that won't let you send the email.
Yeah.
The notes also mention a group called Wheel.
Yeah. On Red Hat systems, like the ones in the lab, there's a group named Wheel.
Yeah.
By default, anyone you add to that group automatically gets full sudo privileges. It's just a quick shortcut for setting up admins.
Okay, so let's zoom out. We've talked about the user. What about the machine itself? You called the etc. directory the brain earlier.
Right. If the kernel's the heart of Linux, etc. is the nervous system. This is where almost all the system-wide configuration files live. It controls basically everything. Time, space, identity on the server.
So give us the quick tour. What kind of stuff is in, etc.?
Well, it's organized. You have subdirectories like cron.daily for jobs that run every day. You have init.d for system services, sysconfig for core things like networking.
And then the individual files. The notes call out bash, rc, xdab, and resolve.com.
Resolve.conf is a big one. That's DNS. You mess up that file, you can't browse the web by name anymore. And stab.dictionary. That's the file system table.
Yeah.
If you make a typo there, the system might not even boot because it can't find its own hard drive.
High-stakes text editing. I like it.
Yeah.
But the most interesting story, etc., has to be the evolution of passwords. We have two files, etcetera-ast and etcetera-shadow.
The dynamic duo, this is a great piece of history. See, originally in the early days, there was just etcetera-past.
Yeah.
It listed all the user accounts, their user IDs, their home directories, and their password hashes.
And the notes say this file has to be world readable.
It has to be. A command like ls needs to read it just to map a number, like user ID 1000, to a name like Jane. If ls can't read that file, it can't tell you who owns a file.
If it's readable by everyone, and it has the password hashes.
Exactly. Even though they were encrypted, having them readable by any user was a huge security risk. Someone could just copy the file, take it offline to a powerful computer, and just crack the passwords at their leisure.
Ouch, as the notes say.
So the solution was the etc. shadow file. They took the password hashes out of the public password file and moved them into shadow. And then they made the shadow file readable only by root.
And what's left in the old file where the hash was?
Just a placeholder, little X. It basically tells the system, hey, for the real secret, go look in the shadow file.
X marks the spot. That's a really clever fix. It separates public information from private data.
Whew. Indeed. It's one of those elegant solutions that just works, so it's stuck around for decades.
Okay, so we've configured the system, but how does the machine actually start? I think for a lot of people, booting is just magic. You press a button and a penguin appears.
It's a bit of magic, but it follows a strict sequence. The BIOS starts a bootloader, and the bootloader loads the kernel.
The kernel being that Vimolus file.
Right. The kernel is the heart, but the bootloader is the doorman. And for most Linux systems today, that's GRUB, the Grand Unified Bootloader.
Sounds impressive. Grand Unified.
It's powerful. GRUB can boot Windows, it can boot macOS, it can boot from over a network, but configuring it, this is where things get dangerous again.
I sense another golden rule coming on.
You guessed it. The main config file is bootgrub2grub.cfg, and the rule is never, ever edit this file directly.
Why? Does it break?
Worse. It gets overwritten. That file is generated by software. If you edit it by hand, the next time the system updates, a script just runs and wipes out your changes. Or you make a typo, and the system just won't boot.
So what's the right way to do it?
You edit template files over at etceteragrub.d, Then you run a command.grub2-mako config.
So it's like compiling code. You write the source, and the command builds the final file.
Exactly. And the great thing about grub2-mako config is that it checks for errors. If your template is bad, the command will fail and just leave the old working config file alone, so the system stays bootable.
Speaking of bootable, the notes say the system keeps multiple kernels around.
Yes, usually the last 3 versions. Because sometimes a system update installs a new kernel, you reboot, and nothing works. The new kernel might hate your graphics card or a driver.
That panic moment.
Right. But because GRUB keeps the old kernels, you can just reboot, go into the menu, and select the previous version. You boot up, and you're back in business. It's a built-in time machine.
That is a lifesaver. Oh, before we move on, I have to mention the fun trick from the notes. The here document.
Ah, yes. The cat text pattern. It's a shell script trick for outputting multiple lines of text easily. The example in the notes is, what, singing the wheels on the bus.
The wheels on the bus go round and round. It's just funny to see a nursery rhyme in system admin notes.
It breaks up the tension. But practically, it's super useful for scripting. If you need to generate a 5-line config file automatically, a here document is way cleaner than running 5 separate commands.
So the system is booted, we're logged in, now we need to control the state of the machine. We used to call these run levels, didn't we?
We did. Run level 3 for text mode, run level 5 for graphics. Now, with systemed, we call them targets.
So what are the main ones?
There are 3 you should know. Rescue.target, which is single user mode, minimal services, no network. That's for fixing things. Then multi-user.target, which is your standard server mode text only, networking on.
And the last one.
Graphical.target. That's the full GUI, what you're probably using on your desktop.
And the tool for all of this is system tittle.
The remote control. System tittle, start, stop, status.
Yeah.
But there's an important difference the notes make between starting a service and enabling it.
Yeah, explain that. They sound like the same thing.
Okay, think of a lamp.
Yeah.
Starting the service is like flipping the switch on. The light turns on now. But if the power goes out, the switch might be off when it comes back.
Okay.
Enabling the service is like wiring that switch to be on by default whenever the house has power.
Yeah.
Enable means start this automatically every time the system reboots.
Got it. So you can start something for right now without making it permanent. That's a crucial distinction.
It is. You don't want your web server staying offline after a reboot just because you forgot to enable it.
Now, eventually we have to turn the machine off, and the notes are very clear. Do not just pull the plug.
Please don't. Linux caches a ton of data in RAM to be fast. If you pull the plug, that data never gets written to the disk. You get corrupted files. You use the shutdown command. It's polite.
Polite.
It sends broadcast messages to all logged-in users, warning them the system is going down. System is halting in 5 minutes. It gives people time to save their work. You can't do that by yanking the power cord.
And speaking of time, that brings us to the last big tool, cronron.
The timekeeper.cron is the scheduler for recurring jobs. Backups, cleaning up log files, you name it.
The syntax for the cron tab file is, well, it's famous for being hard to remember.
It is. It's 5 fields, minute, hour, day of month, month, day of week.
I always have to look that up.
Everyone does. And the asterisk is the wild card. It means every. So if you put an asterisk in the hour field, it runs every hour. The notes warn you to keep it simple.
Right.
If you try to get too clever, you're going to mess it up.
All right, we've covered a lot, the super user, etc., booting, system control. Now, let's talk about the homework. Lab 5.
It is. This is where you apply this stuff.
Yeah.
Task 1 is simple exploration. Go into, etc. Look around, find a couple of files that seem interesting, and figure out what they do.
Just don't edit them if you don't know what you're doing.
Looking is safe. Cat and lessers are your friends. Task 2 is making some cron jobs. They want you to append data to files in your home directory on a schedule.
With a very specific warning, don't fill your disk.
Right. If you make a cron job that writes a gigabyte of text every minute, you're going to come back to a crashed server. Keep the output small.
And task 3 is looking at boot configuration, but there's a huge warning here about the run levels on the VMs.
Yes, this is critical for the students listening. Do not change your run level to 1, 2, or rescue mode on your graded virtual machine.
Why not? What happens?
You lock yourself out. Those lower run levels often disable the network because they assume you're sitting physically at the machine, but you aren't. You're accessing these VMs remotely.
So if you turn off the network,
you cut the cord you're using to talk to it. You can't log back in to turn the network back on. You have effectively bricked your lab.
Which would be bad. The notes say, if you really want to mess with boot configs, go see the instructor during office hours.
Yeah, use his test system. Break his machine, not your graded one. Solid advice.
So when you put it all together, what's the big takeaway?
It's that transition from user to admin. As a user, the system protects you. As an admin, the system assumes you know what you're doing. You have the power to control time with cron, space with, etc., and the life or death of the server was shut down.
But you have to use tools like sudo, vsudo, and grub2melic in a config to make sure you don't accidentally destroy the universe.
Or at least your homework.
Exactly. You have the keys to the castle. Just try not to lock yourself in the dungeon.
Well put.
That's it for this deep dive. Go forth, use sudo wisely, and we'll catch you on the next one.
And don't forget to run your updates.